Now we want to send them the other way. We want to start with expanded, and we want to send it back to 1 log. Okay. Remember, subtract means it's dividing. The add means it's multiplying. So this will be log base 4 of x, z, those are the 2 in the numerator, divided by y. This is the only numerator one. Doing that again, we'll do this in a couple steps. Log base b of r to the 4th minus log base b of s to the 5th. This is a subtract, so it's going to be a quotient. Log base b of r to the 4th divided by s to the 5th. These cubes, and this is the plus, so I think we have log base a of the cube root of x plus log base a of the cube root of y squared minus log base a of x times y. Now combining these, multiply them together, of log base a of the cube root and then x and y squared all over just x and y. Logarithms and other bases. We can use the calculator to find either the natural logs, base e, the ln's, or the common logs, base 10, that's the log button. However, sometimes we use logarithms with other bases. The following formula can be used to convert logs from one base to another. This is the change of base formula. For any positive real numbers such as x, a, and b, where a is not equal to 1 and neither is b, then log base a of x is equal to log base b of x divided by log base b of a. We use these most commonly. We would have, so log of x divided by log of a, or we could use ln of x divided by ln of a. And then we can find an actual number for this exponent. Using that then, change of base theorem, so what we'll be looking for is the log of 20 divided by the log of 4, and to 4 decimal places that turns out to be 2.1610. Log base 2 of 7/10. Let's do this in ln of 7/10 divided by the ln of 2. That turns out to be negative 5.14, turns out to be negative 0.5146. So, review of the rules. The inverse rules are easy to use if you remember that log base a of x is the power of a that produces x. The product rule for logarithms says that the logarithm of the product of two numbers is equal to the sum of their logarithms, provided all the logs are defined and all have the same base. The quotient rule says the logarithm of the quotient of two numbers is equal to the difference of their logarithms, provided all the logs are defined and all have the same base. The power rule says that the logarithm of a power of a number is equal to the power times the logarithm of the number, provided that all the logarithms are defined and have the same base. And the change of base formula says the logarithm of a number is one base is equal to the logarithm of a number of a new base divided by the logarithm of the old base. We'll use our rules of logs to solve this problem. The first thing I'm going to do, since the variable I'm looking for is in the exponent, I'm going to change this to log form. So it will be log base 1.025 of 3 equals 12t. Then I'll use my change of base rule to say that this is log of base 3 over log of a log of 3 over log of 1.025. That still equals 12t. Now I need to divide by the 12, and dividing goes in the denominator. So t will equal log of 3 over log of 1.025 with the 12 down here in the denominator. This is my exact answer. This is the exact. And my approximate answer, when I grab my calculator, and when you do that, log of 3 divided by 12 times the log, you will get 3.7076. Now this time, my variable is not in log. This becomes a little trickier. Okay, the first thing I'm going to do, since I'm trying to get this r by itself, is I'm going to divide by 5. So 1 plus r over 360 times to the 7/20th equals 12/5. Now I'm going to take the 720th root of both sides. I know that seems a little strange. So 720th root of both sides. Now, because this is an even root, it becomes 1 plus r over 360 equals plus or minus, because it was an even root, the 720th root of 12/5. Getting this on one side, I'm going to subtract the r, or subtract the 1. So r over 360 equals the root, again plus or minus, of 12/5 minus 1. And now I need to divide, multiply by 360, since currently I'm dividing by 360. So r equals 360 times plus or minus the 720th root of 12/5 and then minus 1. This would be an exact answer. When I grab my calculator and find an approximate answer, I find out that it's 40.4380 or negative 720.4380. Those are my approximate answers.